joining us for Write Cleaner, Safer, Modern C++ Code with SonarQube. Before we get to the content, I need to hit some housekeeping notes. There we go. That went too far. So first, this will be a 30-minute session, including some brief demos and Q&A. We are recording the presentation. During the presentation, you can use the Q&A box at any time to ask questions. We do have some panelists waiting in the wings to help you out with that stuff. In a few days from today, you'll receive an email with a link to the recording of this session, as well as all the questions asked during Q&A. Whether or not they got answered today, the follow-up will include answers to all the questions. At the end, you'll receive a feedback survey. Please, please, please do fill it out. Tell us how we did. Tell us what we need to work on. Tell us what we did well. Tell us what you'd like to see us cover in future webinars. A brief agenda. I'll start with some introductions. We'll talk about what we can find in your code. You'll see some product in action demos to show where we can find stuff in your code. We'll talk about integrating the tools into your systems and then how to get them. So here we go. Again, thanks for coming to Write Cleaner, Safer, Modern C++ Code with SonarQube. My name is Ann Campbell. I'm a coder and a SonarSourcer since 2013. I've been active in the community since long before that, so if you've ever interacted in the SonarSource community, then we've probably encountered each other. So hello again. I'm joined today by Loic Joly. Loic, would you mind saying hello?
Hello everybody, I'm Loic.
So Loic is a C++ expert and a SonarSourcer since 2018. His day job is crafting C++ rules to find interesting things in your code. And in his spare time, he represents France on the ISO committee for C++, as well as being a member of the MISRA C++ committee, and they're currently working on the next version of that standard. I also want to introduce the company. SonarSource was founded in 2008 by 3 developers who came together with the goal of writing tools to help other developers improve their code quality and security. Specifically, they wanted to write tools for developers and development teams, not managers, but developers, that are simple and transparent, easy to integrate into your workflow, and accurate and helpful always. And specifically what that means is no false positives. We're human, it happens, but when you find a false positive, please do tell us. We will be all over it and get it fixed as quickly as possible. Now, those 3 guys that I mentioned started with Java because they were Java developers, and we have huge adoption in the Java community. We're popular with thousands of developers of Java and a number of other languages. We've since expanded to cover 27 languages, including C++, and we consider C++ one of our flagships. And what that means is that in C++, you're going to get just as rich and valuable an experience as Java developers do. This company has produced multiple tools, and you're going to see 2 of them today, SonarQube and SonarLint. Our mission statement at SonarSource is that every developer and development team should use our products for code quality and security. We see that as mission possible, and specifically we see it as mission possible that every C++ developer and development team should use our products. And so now let's talk about why we think that's mission possible. We work hard to bring you the right data at the right time and in the right place. So we write interesting rules that raise valuable issues on your code. We present those rules where you work. We give you a great experience around those rules, and we make it easy to fit it into your tool chain. Starting with the rules and issues, we divide it into what we call the 3 pillars. So maintainability, reliability, and security. Diving into that, starting with maintainability, maintainability rules raise code smell issues. And this is about more than naming conventions and where the curly brace goes. Studies differ. Different studies come up with different numbers. The most widely cited number is 90%, but I've seen studies that come up with as high as 96, 97% of project costs are spent in maintenance. Now, as developers, we understand that project costs means development time. So that's like 95%, 97% of your time that you're spending in old code. And when you put it like that, it becomes obvious that the more maintainable, the more readable, the more understandable you can make your code base, then when you need to do something, the less of your time you're going to spend figuring out what the code does, and the more of your time you can spend solving problems. And that's why you got into this, right? So now I'm going to turn it over to Loic, and he's going to show us some maintainability rules that he and the team have crafted to find interesting things in your code. Loic?
Sure. So let's get started with this first rule, which is about const correctness. So you can see in this screen that the function encode takes as a parameter pointer to uint4, and this pointer is not a const pointer. And if you look at the body of the functions, all that is going to happen on this is that we are going to read this input. So there is no reason for this to be non-const. So we have a rule that says you should replace it to point to const. And it will allow the function to be called in more context, and it will also make the code clearer to anybody who is going to use this function. This next rule comes from Qt, and it's a very well-known rule of rule of 5 in this case, which means that if you have a class that defines a destructor, it should probably also define other special number functions such as copy constructor, move constructor, copy assignment operator, and move assignment operator. In this case, we have a class which has a destructor, and in this destructor, it's deleting a pointer project, which means that it owns the pointed object. If ever the object project builder result this is copied, we are going to have two objects that points to the same project. And when both copies are going to be deleted, both of them are going to delete the same project. So it's a double delete, which is undefined behavior. And finally, for maintainability, we have a rule about mixing inheritance and overloading. In this case, when you look at the base class, which is on the right, we can see that it overloads the function white with a bunch of different parameters. And one of them is takes a VC manifest tool as argument. And when we look at the derived class on the left, we can see that we override all those write functions, but one of them is forgotten, which means that if you access to this class through the derived class, you will not be able to call this function. It's hidden by the other ones. It's probably not what you want to do.
Thanks, Loic. So now let's talk about reliability. Reliability rules raise bug issues, and as soon as I say bug, then it becomes obvious. Bugs are bad. Bugs make your software do things that you didn't intend, and bugs erode your reputation, and obviously you want to get them found and fixed as quickly as possible. Would you share some bug rules with us, Loic?
Yes. So the first example is about this call to forward. We are trying to forward a variable to another function by calling std_forward on it, and then the issue we raise is that in fact a result value is not a forwarding reference. So why is that? We can see a secondary location that a result value is of type result value ref. This double ref, which was introduced in C++11, can mean two things. It can mean forwarding reference, or it can mean value reference that is used for moving. And the difference between those two is that if the type is a template parameter, then it's going to be a forwarding reference. If it's a normal type, it's going to be a value reference. And in this case, it's not a template parameter. So what should we do with this value is mostly move it or steal some information from it. It's not designed to be forwarded. So it's probably not going to do what the developer expects. The second one is also a tricky one. It's you are using a mutex to protect some data in a multi-thread context, and that sometimes we want to lock this mutex. And when we do that, we want to use the RII pattern so that we lock the mutex in the constructor of a lock object, and we unlock the mutex at the end of the function when the lock object is destroyed. But in this case, it was forgotten to name the lock object. So it means that in fact, you are creating a temporary lock object, which is going to be destroyed immediately. So we believe that the access to the shared state is protected by the lock, and in fact it's not. And it's especially tricky because it may run correctly. It's the problem with multi-thread bugs. It happens only when the synchronization between threads happens in a very specific way. So it's a kind of bug that can be undetected. I mean, it's in LibreOffice, so it's a very well working program. it means that it's probably been not detected for quite a long time, and yet it's a bug, and that's where static analysis can help you a lot. And finally, for this bug in Clang, it's also a tricky bug for different reasons. Here, we are calling a function check with two parameters. And in one of the parameters, we are using the variable sReglock to read it, but the other parameter is calling path register on another, sorry, not the same variable sReglock, which, and if we look inside of the definition of this path register function, we can see that this variable is in fact modified. So it means that when you are calling the check function, at one point you are modifying a variable, and at the other point you are reading the variable. In which order are those operations going to happen? We don't know. It's not specified by the standard. So it means that with different compilers, or maybe different options of the same compilers, it's going to behave in different way. It's undefined behavior too. And it's also one which is not tricky to detect because it might happen as you expected it to happen, just by luck.
Thanks, Loic. So now we move on to the security domain. At SonarSource, we divide security into two subcategories. The first subcategory is the standard vulnerability category. Vulnerabilities are the holes in your code that attackers can stroll through to lay waste to your systems, your data, and your users, and obviously damage your reputation. At SonarSource, we want to shift left, finding those security issues. We want to put the tools in developers' hands. So we find with static analysis issues in your code, so you can get them fixed and while the code is still fresh in mind. Loic, would you show us a vulnerability?
Yep. So for this vulnerability, we are looking at the function memset. And what is interesting before looking at the function call itself is to look at the comment at the top of the functions. So in this BusyBox example, they want to clear a buffer so that people who have access to the memory cannot read some data, which is sensitive data, which is inside this buffer. For that, they do memset and putting 0 inside of this buffer, and then they will free the buffer. The problem with that is that the compiler is clever enough to detect that you are calling memset on a memory region that is going to be deleted. So from the abstract point of view of the machine, this memset is totally useless. It's going to be removed by optimizer in many cases, and almost all cases it's going to be removed by optimizer. So the additional protection that the developer expected to have by using this memset is gone. It's not there. So we advise to replace it by a call to memset_s, which is a specific function which cannot be optimized away.
Thanks, Loic. The other subcategory of security is security hotspots. Now, a security hotspot is when you're using a security-sensitive piece of code. My favorite example of this is setting a cookie. If I set a cookie in your browser with personally identifiable information or financially sensitive information, such as your date of birth, your mother's maiden name, and your social security number, then that's a problem. But if I'm simply setting a cookie in your browser with the current timestamp, then that's no big deal. Statically, it's very difficult for us to understand whether the information is a problem or not. And so what we do is raise a security hotspot to bring a human reviewer in so that in the context of the code, you can understand whether or not there's a problem and something needs to be done. We segregate these from normal vulnerabilities, and we give you the tools and the context to know for sure whether each security hotspot is actually a problem. You're going to see a preview of the separate interface that we give you for this when Loic shows you a hotspot in just a second, and I'll show you a little bit more in the demo a little bit later. So Loic, your turn.
So this hotspot is related to to POSIX file permissions. And as you probably know, when you are using POSIX permissions, there are information that are related to the current user, to the current group, and to others. And if you give permissions to others, which is the last digit of this number, it means that anybody on the machine can access the file. In some cases, it's perfectly fine. It's just what you want, but not in all cases. So that's why you have a hotspot when you open a file with this specific permission. And in that case, if you look at the name of the variable, it's called Earthbit. It means that it's probably not something that anybody should be able to tamper with. So it's probably a real issue in this case.
Thanks, Loic. So briefly, I want to talk about what rules are on when you run an analysis. We offer almost 500 C++ rules right now, but they're not on all by default out of the box. Out of the box, you get what we call the SonarWay quality profile, which we believe is a good default. So these are all the rules that raise what we consider to be no-brainer issues, the issues that anyone on a team is going to look at and go, oh, we need to fix that. You can create as many profiles as you like. And so when you create your own profiles, this is when you're going to add in rules for specialized conditions. Like if you're writing to the MISRA standard, then you would add those rules in. We don't have those on by default because they're not always appropriate for every situation. So as another example, if you're writing to or migrating to the C++ 17 standard, then you would turn on those rules. But if you're in a C++ 98 context, those rules are just going to be irritating, and so they're off by default. So that's rule selection. Now let's talk about where you can get these rules. So first, a brief overview of the typical workflow. Starting here on the left, we have the developer in the IDE. Code starts in the IDE. Once you're happy with it in your IDE, then you're going to push to the central SCM repository. From there, you might create a pull request. That leads to peer review. And then after you peer review, you're going to merge into master. So that's the typical workflow. Let's talk about how we fit into that workflow. As I said, code starts in the IDE, and we do too with SonarLint, which is a free IDE plugin for Visual Studio and Eclipse. You can just download these from the marketplace and get going. With Eclipse, you are going to need to be connected to a SonarQube instance, but with Visual Studio, you can just install it and go. Loic, would you show us SonarLint?
Sure. So here I am in Visual Studio, and I have a to-do. As you can see, there is this green squiggle on the screen, which means that we added some information. We have a rule that detects to-do commands, because if something needs to be done, why is it not done? So let's do it. I'm going to add the lock as specified in the command. So I'm adding a scope lock, and I'm going to lock on the mutext that is provided for me in the bar function. So then I'm going to save my code, and oh, there is another green squiggle. What is it about? Well, it's exactly the rules that I showed you before in the screenshot. We forgot to name the lock, so it's not going to lock for the whole function. So okay, I'm going to correct it. I add the lock, save again. Now the green squiggle has disappeared, and we can also remove the to-do because it's no longer needs to be there. And then here we have the trigger function, and we also have a green squiggle because it says that we should use override or final instead of virtual. I'm in a modern C++ context, and instead of just saying that this function is virtual, in fact, it overrides the function for the base class. So I'm just going to say override. And as soon as I save, the green squiggle disappears.
Okay, thanks, Loic. So that was the demo of SonarLint. Now I want to show you static analysis in your pull requests. We do have full support for GitHub, GitLab, Azure DevOps, and Bitbucket Server. So I'm going to jump out of the slides and into GitHub here, into the pull request that Loic has thoughtfully prepared for the webinar. We see that this pull request has failing checks. So down here in the checklist, we've got a failure here, SonarQube analysis. The quality gate has failed. Just as a side note, a quality gate is a list of release criteria that the team agrees on and applies to the project in SonarQube, and it's automatically applied to pull request analysis as well. So I see here in the checks that my quality gate is failing. I also see in the conversation that the quality gate has failed. I do see a lot of green here, but I've got the ability to click through to details. I do want to check this in the checks tab here, which I can jump to. And once I'm in the checks tab, I get a little bit more detail. So I see quality gate failed, failing lozenge. And now I see why my quality gate is failing. So I'm failing because I've got zero coverage on new code, and the team is requiring at least 65%. And I've also got 3 new critical issues. So now I want to click through and see the pull request analysis in SonarQube. So this brings me to the front page of the pull request in SonarQube, where again I see the current quality gate status on this pull request, and I see why this pull request is failing the quality gate. I want to see those critical issues because this is what I need to do to be able to pass the quality gate and merge my code. So here's my list of issues. I'm going to click through to see the issue in context. And I see that it's telling me to replace the standard function with a template parameter. Now, personally, I coded C. I never graduated to C++, so it's not immediately obvious to me why there's a problem here. Fortunately, I have easy access to the rule description, which will help me understand as a new coder or someone who's moving to C++ from another language, why it's a good idea to follow the rule, what bad thing can happen if I don't follow the rule. And I also get some code samples. So it starts with a non-compliant code sample that shows me the rule broken. And then I've got the compliant solution, which shows the broken code fixed. And together what those do is give me a template for fixing my own code. So that's really useful. So that's the quality gate on this particular pull request and what I need to do to fix the quality gate. I do want to jump out of the PR and show you the project at large. Now, as a side note, we're in next.sonarcube.com. This is our internal dog fooding instance. So what you're looking at is a real life project for SonarSource. This particular project is currently passing its quality gate, so it is releasable to production. But I do want to show you there are some existing issues here. So I see that I've got 8 open bugs. All things considered, that's not bad. I can see all the rules that are being violated here if I'm curious. Or I can just jump in and start looking at the issues. Now, this one is interesting because I have a lot of secondary conditions on it. The list is collapsed by default, but I want to expand that to see all of the secondary locations. And when I do, it becomes obvious that this issue crosses multiple files. So we've worked hard here to give you a good interface to help you understand the issue context. So you have a full picture of what's going on and what you need to do to fix it. In this particular case, this wanders back and forth across 2 files, and we've presented it to you in the correct order to make it as understandable as possible. So here I've got an uninitialized field at the end of the constructor call, and the understanding for this starts up here, line 97, source manager, and then I can navigate through my secondary locations, read the message with each one of them until I get down to the bottom to understand what's going on, what I need to do to fix it. So that's what I wanted to show you here. I did also want to show you the security hotspots interface like I promised earlier. Fortunately for the team, there are no unreviewed security hotspots in this project. So good job, guys, and thanks for making my demo more difficult. I'm going to jump to a different project here. This is actually the hotspot that Loic showed you earlier in the screenshots. So this is the code you saw. And now you can see the larger interface around that. So here on the list, I've got a severity sorted list of open hotspots that need to be reviewed. And I've got the issue in context. At the bottom, I've got some information to help me understand what the risk is in this particular case. I've got some data to help me understand whether in this particular context there actually is a problem. And if I determine that there is, I've got some guidance on fixing the problem. As a hotspot reviewer, I've got a few choices here. I can assign it to myself for fixing or to someone else for fixing or further review. Or I can say, well, okay, this is fine, there's not a problem here. Or I can say, we've fixed the context, the particular call remains, but we fixed the context, so this is okay. And because I want you to see what happens, I'm gonna mark this safe, change status. Of course, the demo effect kicks in. So the server is taking a little bit of more time here than I expected. What happens here is that this one goes away and I'm automatically moved to the next one in the list so I can continue my review. The idea here is that you've got one person who's going to sit down, chug through these, see which ones actually need working on, and then you can go back and work on them later. So that's what I wanted to show you here. So now we've seen analysis in your PRs, and we've seen analysis in SonarQube itself, where you can coalesce the team around a shared definition of quality. So now let's move on to how this fits into your tool chain. So first, we have good integration with Jenkins CI, GitLab CI, Azure DevOps. We make it easy to break the CI build when your project is failing the quality gate. Same for PRs, obviously. We support Windows, Linux, Mac OS, and we properly parse and understand C++ 98 through 17. And now Loic's going to tell us about how this actually works with your build.
Okay, so here you have a view of a typical continuous integration system where you check out the code, you launch a build that is going to build all CPP files one after another or in parallel. It may use a build cache to avoid computing the same thing all over again, and is producing build artifacts. So what we need to do on top of that is that we need to get some information about how the build works. So in fact, instead of just launching the build, we are going to ask you to launch what we call a build wrapper, which is going to eavesdrops on the actual build. It's going to listen to all the compilation process that are going to be launched, and it's going to grab all the interesting parameters, because you know that to understand C++ code, you need to know include files, so you need to know include paths, you need to know macros. So we are going to look at all of them and write them into a file which is called buildwrapper.dump.json. And then we can run the analysis. It's going to take as input this additional file, and it's going to analyze all the files one by one. And when I say one by one, I'm not totally right, because we can also run it in parallel. It's an optional parameter, but we strongly advise that you configure it to have parallel build. And we can also have an analysis cache that we avoid recomputing the same file. Is nothing has changed. It's also optional, but we also advise you to use this. It can really makes your analysis faster, and it's very important to have fast analysis if you want to analyze every pull request.
Thanks, Loic. So we've talked here about you launch the build wrapper and then we launch your build. That may make you wonder what build processes we support. So these are the compilers we support. I'm not going to read through this. I think it would put everyone to sleep. The takeaway here is that we do support most popular compilers. At the end, you'll have a link that will bring you back to this full list so you can find your own compiler in there. I do need to tell you, for people who are familiar with SonarSource, SonarQube, you may be aware that most of the languages we analyze for free. So Java, C#, JavaScript, we analyzed 15 languages for free. C++ is a commercial language for us. We price by lines of code, not by seat. We do have a more the merrier approach to static analysis. We feel like every developer should have access to these tools, should be using these tools, and hopefully should be learning from these tools. So we price by lines of code to encourage that access and that use. It is pretty reasonable. We start at $150 per year for up to 100,000 lines of code. We do support more than 1 million lines of code. I just didn't feel like inflicting the entire pricing table on you, but that is available. And so now, in summary, we work hard to write interesting rules that raise valuable issues on your code with few false positives. Again, if you do find a false positive, please do let us know. We will be all over it. We give you feedback throughout your workflow. So in your IDE with SonarLint, in PR analysis, and in SonarQube itself. We work hard to fit into your environment, and we give you a great user experience with all of these tools. It's time for questions now. Unfortunately, we're about 30 seconds from the end. So Loic and I are going to stay afterwards to handle a few questions. But for those people who do have to drop off on time, I do want to hit the final housekeeping notes first. So thank you for joining us. Please do take the survey. There will be an email in a few days with this recording and all the questions that got asked and all the answers to those questions. If you want more information, you can go ahead and go straight to sonarcube.org/CPP, and that does include the compilers list in case you didn't have time to find your compiler on the list. And now Loic